The vertex form of a quadratic equation gives us another option for graphing a quadratic function and identifying its key characteristics. So we begin first by looking at the vertex form, and right from the jump, we can identify the vertex. The +1 suggests that this is going to be a graph that is moved 1 unit to the left. The -3 suggests that the graph will be down 3 units. And because of that, we know that the vertex will follow that and move 1 unit to the left and down 3 units. And here is our vertex. So we know that our vertex will be at the point -1, -3. Because the 2 is positive, we also know that this graph is going to open upward. And because the graph has a vertex at -1, -3, we know that the axis of symmetry will be at the line x is equal to -1. And we can sketch that axis of symmetry on our graph so that it can help us with graphing some of the other elements. Identifying the intercepts is very similar to what we did when the equation was written in standard form. We're going to use what we know about the intercepts and use those values and substitute them into the vertex form. So we're going to give ourselves a little bit of room to do this next part. And let's begin by identifying the y-intercept. That one's a little bit easier. Every point that's on the y-axis shares in common that its x-coordinate is 0. That being said, if we want to find the y-intercept, we're just going to make x equal 0. And we'll see that we only have one variable left. That's the y. So we're just going to walk through the simplification of this expression. 2 times 1 squared minus 3. 2 times 1 squared is 2. 2 minus 3 is -1, which tells me that my y-intercept is going to be at the point 0, -1. So my y-intercept will be right there, 1 unit to the right and 2 units up from the vertex. Because of the symmetry of the graph, and just like we did when we were written in standard form, that point can be reproduced over here on the other side as another point to the parabola. So while we had a point at 0, -1, going the other way, we know that we're going to have a point at -2, -1 as well. And you can already start to see, because we've identified that this graph is going to open upward, you can already start to get a sense of where those x-intercepts are going to be. So it's nice to have the first part of the picture done so that you can then use that information to help you check to make sure your x-intercepts make sense. For the x-intercepts, we're going to change this just a little bit, and instead we're going to have y equaling 0. So we're going to write our equation just as it was with the x, but this time y is going to be 0. Adding the 3 over to the right-hand side, we're here. Because of that square around that expression x plus 1, the square root method ends up being a really nice route. You could have multiplied this whole thing out, had it set equal to 0, gone through all of those steps that we did before, but if we're already in vertex form, it's a little easier to go to the square root method. We're going to divide by 2 on both sides, and then we're going to take the square root of both sides. Now the square root on the left is the square root of 3 over 2. The square root on the right just leaves us with x plus 1. We want to account for both solutions, so make sure we have our plus minus in front of the radical. And we're not a big fan of the fact that that radical has a radical in the denominator, the square root of 2. So we rationalize. We multiply the top and the bottom by the square root of 2, and we get that it's really the square root of 6 over 2 equal to x plus 1. We're going to subtract the 1 over to the left-hand side to get the x by itself, and we get that our intercepts are at -1 plus or minus the square root of 6 over 2 is equal to x. Now, for the sake of graphing these, that's a really strange expression to have to graph. The decimal expansion might be a little bit easier to work with. If you use the plus sign, you get 0.225, which makes sense as an intercept right about there. And if you use the minus sign, you get -2.25, which makes sense as an intercept right about there. maintains the symmetry, definitely maintains. I mean, look at this. That's a perfect demonstration of how it maintains the symmetry. -1 is the axis of symmetry. And then this plus minus is saying go up that amount and then down that amount. So it has to be symmetric. And we draw our parabola through all of those points. Same tenets as before. We want to make sure that we're not only just drawing our parabola, being careful to draw it, but we're also making sure that it has that nice rounded U shape at the bottom. Beyond those 5 points, the 2x-intercepts, the y-intercept, its reflection point, and the vertex, we are not so concerned with did we get all of the other points exactly right. I'm sure that the rest of the points on this parabola are not in the correct location, and that's okay. That's not the important part of this. The important part of this is, did you get those key points? Can you see the key characteristics? And then do you have the graph moving in the correct direction? Everything we found in relation to this graph reflects the fact that this is an upward opening parabola that would have a y-intercept and would have 2x-intercepts. We also want to take a second to talk about the domain. So the domain of this function is all real numbers, but our range is going to be anything above where our bottoming out was. Our bottoming out point was at 3, and we know that we proceed up from there. It may take a really long time for this parabola to sort of open up and cover all the space, but it will get there. It will cover all the y values that are above 3, and every x is available as an input to this function.